Boom.
All right.
Hey,
It got erased.
wait, how?
The boards.
You need a blue. You need a blue, a red, and a black marker, right? Probably some. All right. So, did we develop a rule yesterday to understand how forces, balanced and unbalanced forces, go with acceleration? We did. Did we write it down?
Yes, the other board.
Okay. Can someone tell me their rule from their board?
It was on the other one.
On the other one.
When
When
there's
forces are
acceleration,
balanced, there's no acceleration. When forces are unbalanced, there is acceleration.
Oh, my back.
When forces are
Is that the rule?
Yes.
That's the rule?
Yeah.
So if the forces are balanced, you are not accelerating. Now, that could look one of two ways. Given the board yesterday, what could this look like? So the speed could be 0 and staying 0, or the speed could be constant. True? That's what we got from yesterday. So the goal for today is to see if this rule was just specific to that, or if this rule is generally applicable to everything. And we're going to use our block to try to figure that out. Does that make some sense?
Yeah.
All right. And again, I could tell you, but what fun is that? Actually, it's not that I could tell you, although I could tell you, it's if you could figure it out on your own, that'd be great. I think you're missing some forces. What is the difference between the block and the cart?
The block has friction.
That's right. There's friction between the block and the table.
Friction.
All right, well, let's look, and let's just compare them. All right, so we have a block over here. Okay, like this. Let's look at this thing. Okay.
Yeah, the friction area would be smaller because
Okay. All right. I like that. Brendan, let's see yours. Okay, we got.
One camera.
All right. What do we have over here? Somebody didn't label their forces. I wonder who that is.
That was an accident. No, it's technically done. Yeah, it is never on the bottom.
Oh, you have the key?
Yeah.
Oh, don't put on that for
I like this.
I said, wait, all right.
I'm sure Mrs. McCain is going to love your waving. All right, so you guys are having a really interesting conversation over here that I like. So tell us about, Toshi, hold the board, and Danny, tell us about what arrows you drew and why you drew them. No, Toshi, you hold the board. And Danny, you tell us about the arrows.
Okay.
Thank you.
So it's not moving, right? At the first stage, it's not moving. So the arrows would be equal, 0, not moving. And then when the wood is pushed, we introduced, is this an accelerating arrow or a motion arrow?
Well, remember, these are forces, okay? George, is there something in your ear? Is there something in your ear?
My bad.
That's weird. Okay.
And then in this one, this arrow would be bigger to represent that it's moving, although we also included a friction force, but we purposely made it smaller because it's moving forward. And then in this one, it's stopped, meaning that the friction force took over this force, and that's why we only have one friction arrow in this one.
Is it stopped in the last one? Or is
Actually,
it?
it's moving, but since there is no hand pushing it, the friction is still has more force on it than the direction does. or the movement?
The movement.
Yeah.
Is the movement a force?
No.
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 Or the,
Well, listen,
I'm confused.
listen, we are trying to figure this out in the moment, okay?
The movement is caused by the second.
Whiteboards are not to have right answers on, right? We're not just putting up right answers. We're not posterizing. We're trying to make meaning in the moment. You guys with me on that? So what we're doing right now in this little dialogue that we're having, or trialogue, is we're trying to figure out what's what. Okay? So take a moment and label your arrows so we can figure out if we know what's what. Is that cool?
Yes.
Okay. Do you guys have? Where's your? Oh, can you hold it up so we can see it? All right, put it on your lap so you're not hiding behind it. Thank you. All right. Cole, is this your group?
Yeah.
Can you tell us about your forces and why you chose what you did?
We chose these forces because when the force is applied with the hand, the friction is still there, but the hand's applying more force, so it keeps moving. And then on the third one right here, we put more friction because it's not getting any acceleration from the hand, and it's just friction slowing it down.
Why do you think the friction in the second one is bigger than the first one? I don't know if it is or not. We don't even have a way to measure that, but that's what you wrote.
Because didn't you say the car's frictionless?
No, in his third diagram versus second diagram.
Oh, I thought you were saying. Oh.
I know, it's okay. Why?
Restate the question, please.
So as Cole said, and your diagram indicates, the second or the red arrow on your third diagram, your friction is bigger than your second friction.
Well, we just had that because the friction on the first one, it can't be bigger than the force of the hand, or else then it wouldn't be moving. Or if it was bigger than the hand, then it would be saying that the friction is pulling it back, but that's not possible. And then on the third diagram, we just have the friction is bigger because it's slowing down the object and making it stop.
All right. Laura, what were you guys talking about? You were having a conversation. I want to get in on it.
Well, we were talking about our friction arrows because we weren't sure if like they were supposed to be the same or if they were supposed to, one was supposed to be shorter than the other. We weren't really sure like what the friction like was, what the difference was.
Sure, we don't know.
Yeah.
They had theirs bigger, yours are the same. I like that. I'm noticing on your board, in your middle one, you have the hand force bigger than the frictional force.
No.
Why?
So that's because if the friction was greater than the hand, then it would be moving backwards, not forwards. And that's why it's moving forwards, because the hand is pushing it.
Friction technically can't like. hold
If
something.
the friction was bigger than the hand, it would be moving backwards.
That's
Yeah, because when the forces are unbalanced,
not what I mean.
it accelerates.
So, okay, so I want to parse out the language because I think that's important. You said it would be moving backward, but I think Brendan wanted to jump in on this and say, kind of clarify what he thought you meant. Whoosh. Which was what? What do you think he meant? Because I agree with you.
No, I'm just saying like, so like for this one is.
Hold on.
Oh, sorry.
I got it.
Thanks. So for this one, this is smaller than this because it's still moving forward, right? It's decelerating, but it's still like, well, it's accelerating at this point because the hand's pushing it. But here, it's decelerating because there's no force this way. So that's why it's slowing down. So even though this one's small, it's still accelerating, just like negative acceleration because it's not speeding up, it's slowing down. So that's why.
So, I want to make sure that we are equating unbalanced forces with acceleration and not necessarily the direction of motion. Right? Because let's look at the third one over there. Brendan, which direction is it moving, left or right?
Right.
It's moving to the right, but which way is it accelerating?
Left.
It's accelerating to the left because which direction is the unbalanced force?
Left.
To the left. You with me on that? So I want to go back to George's comment, and what he said was, if the frictional force was bigger than the hand force, what would be true? Okay, so check your neighbor on this one. If the frictional force was bigger than the hand force, what do you think would be happening to that block? Check your neighbor.
In the second diagram?
In the second one.
then it wouldn't move.
Wouldn't it just be like still?
Yeah, I don't think
I think it just wouldn't. It would just be like staying. It wouldn't be moving.
huge rock, heavy rock. There's probably a lot of friction and it doesn't move backwards.
Friction just slows it down.
In general, that's true. Right? Like this middle one, there's no friction, then it would be accelerating more. Here, there's friction.
Friction can't technically like.
So it's usually a reactive force. So like, if I just put a block on the floor, there's no friction. But if I try to push it, then all of a sudden friction shows up because it's a reaction. All right, so who wants to coach us up here? Let's assume that the block is moving. Let's assume the block is moving to the right, but all of a sudden the frictional force is bigger than the hand force. What's going to happen to the block?
Stops moving.
Go ahead, George.
It's gonna stay still.
So what if it's already moving, though?
It'll stop.
So if it's already moving, and all of a sudden the frictional force is bigger, it's going to slow down, yes? Okay. So what I want to know, okay, given your diagrams here, is it consistent with our rule?
Yeah.
All right? Acceleration means one of two kinds of motion. What's one kind of acceleration?
Speeding up.
Speeding up is one. What's the other one? Slowing down. It's a change in velocity, yeah? So if your forces are unbalanced, your object is either speeding up or slowing down. Is that consistent with your blocks?
Yep.
We good about that? So this rule looks really good. What I want you to do next is I want you to look at your boards and I want you to see, is there a relationship between the direction of the acceleration and the direction of the unbalanced force? All right, so take one of your markers and for each of your diagrams, write unbalanced force, give me an arrow or a value, and then write under that acceleration and give me a value or an arrow. Okay? Do that right meow.
Okay.
So here, there's a no.
Just the intro.
Yeah, so they'd be the same.
Yo, unbalanced force.
I'm getting it.
You're talking about the intro.
So like,
Obviously.
So I'm just doing what I need to know.
Yeah. So it's different directions.
Yeah, this one's
Okay, so.
Maybe it's the direction of the
Alright, so
where.
then-
Forces are unbalanced.
So it's
you said you want
unbalanced
this,
and
right?
then
Can we just
on the
fire
left.
acceleration would just be back? Because
You know, like if it's unbalanced. It's different than that area.
Okay, what do we got? So this one, I don't know about the unbalanced force. Unbalanced force and acceleration. So you can do the velocity all. So unbalanced force here, acceleration 0, velocity 0, and the unbalanced force is 0. Because they're,
This is unbalanced.
It's
Pointing in this direction. So acceleration. So same thing as this with the arrow.
So this is interesting, right? Here, no unbalanced force, no acceleration.
Right.
Here, unbalanced force to the right, acceleration to the right.
Yeah.
Here, unbalanced force, acceleration. Is that a coincidence?
That's how it works.
You're like, no, that's physics. So, I don't know.
Nice work.
So here, no unbalanced force, no acceleration. Here, unbalanced force, which way, left or right?
Right.
And what way acceleration?
Yep.
Right. Here, unbalanced force, which way?
And let me say, that hand.
That's my dad said.
Except he doesn't really like, kind of lost it.
So is there a rule to be developed there?
friction.
Okay.
But the hand is the way that.
It's accelerating.
Accelerate now. You did. That's like you did. Just like break that.
Acceleration.
That's like the first book I read.
And unbalanced force. I don't know on this one. This one, velocity.
Such a good book.
This
Oh
one,
my god, it's not.
it's also speeding up.
Oh.
So if it's speeding up, I have to be in the same
Don't
direction.
worry about it.
So that's why the
Like, that's.
what about this unbalanced force?
Well, not necessarily.
Yeah.
All right, you guys ready? What's the rule?
The end is,
What's the rule?
but it's not necessary.
The direction of the unbalanced force equals the direction of acceleration.
Brendan, have I characterized your rule correctly? Do you guys want to agree or disagree with Brendan's assessment? I mean, I wrote it down, so you're getting a tacit indication that it's probably right, but I also visited each group.